All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll show you the correct answers. So for this factoring, you're going to start by taking out the 3, because that's what they have in common. And you're going to have x squared minus 4, and then that'll factor as x minus 2 times x plus 2. So this would be your answer there. For the math knowledge question, you are going to say 2x minus 3 times 2x minus 3y. So 2x times 2x would be 4x squared. Then we're going to have the minus 6xy, and then another minus 6xy, and then we're going to have plus 9y squared. So when you combine your like terms, you end up with 4x squared minus 12xy plus 9y squared. And so that would be A for your answer there. Now we're going to look at lesson 92. We skipped lesson 91. It was dealing with more geometric sequences and stuff, and I told you that we are skipping all of those lessons so that we can focus on some pre-cal concepts that we have towards the end. So we're looking at lesson 92, probability of either. So hopefully you'll understand the probability of either after this lesson, and it also talks a little bit about notations for permutations and combinations in this lesson. We're going to be looking at mutually exclusive events. We're talking about probability of either. Those are events where one event occurs, the other event is excluded and cannot occur. So you are either going to be a boy or a girl. You can't be both. If you flip a coin, you're either going to flip a heads or a tails. You can't do both. So you either you have one or the other. Okay. Probability of either of the two mutually exclusive events occurring is the sum of the individual probabilities. So you're going to add the sum of the individual probabilities. So we're going to look at this one here. It shows events that are not mutually exclusive, and we have some boys and some redheads, and we also have some redheaded boys. Now what we want to look at is the number that are either boys or redheads. Okay, so the number of boys that we have, 1, 2, 3, 4, 5, 6, 7. We have 7 boys. The number of redheads that we have is 4. Right? 7 plus 4 is 11. However, we counted 2 people twice. So we actually need to say 7 plus 4 minus 2 to give us a 9. That is how many we have that are boys or that are redheads. Okay? And the way that you would write it using, yes, to subtract for this, we must subtract the number of redheaded boys, that 2 that we overcounted because we counted them twice. The way that you would write it, using your union and intersection symbols that we talked about with your Venn diagram project, the probability of the redheads union the boys, so redheads plus the boys, is the probability of the redheads plus the probability of the boys, but minus where they overlap, the intersection of the reds and the boys. Okay? So you're going to do the boys plus the redheads minus the redheaded boys. Okay? So let's look here at an example. We have a card drawn from a full deck. What is the probability that it is an ace or a black card? So in a deck of cards, out of the 52, 4 of them are an ace. And out of the 52, 26 of them are black cards. But how many are both an ace and a black card? 2. And so we have to take out 2 of them. And so if you subtract, you would end up having 28 out of 52, which will reduce to 7 out of 13. So you have a 7 out of 13 chance of drawing an ace or a black card, or possibly a black ace card. Okay? Looking at another example. We have an urn that contains 4 white marbles and 3 black marbles. 2 of the white marbles are rough and 1 of the black marbles is rough. What's the probability of drawing a ball that is either rough or white? So we have 7 balls in total here in our urn, and how many of them are white? Well, 4 of them are white, and then how many of them are rough? Well, it says we have 2 rough and 1 rough, so a total of 3 that are rough. But how many are both white and rough? How many did we accidentally overcount? 2 of the white balls are rough, so we have to subtract those 2. So you should get 5/7 for the probability of a ball that is either rough or white. Now I realize that some of y'all may already be subtracting it in your head. You may not be actually writing it out, and that is fine with me if you want to do it that way. Okay? The book also shows notations for permutations and combinations, but I've actually gone over those already whenever we talked about combinations and permutations earlier in the year. So we're not going to go over that. But if you need to, you can look at page 540 in the book to see a review of that information. But hopefully that helps you with probability of either. You do get to omit 7, 8, 9, 10, and 14 on your homework. So you only have 25 problems to do tonight. Make sure that you do those so that we can go over any questions you have tomorrow.